Alright, I just got this thing at Micro Center today, and I'm going to do a few tests on it. Load it down with some things, see how accurate the voltage reading on the display is, and so on. So without further ado, let's get our high-tech box cutter and cut into it. Yes, I'm moving it towards myself. Don't worry, I'm nowhere near it. Just retract it. Open it up. And okay. You did a pretty good job packing it. Here's the bag for the user manual. Oh, it came with test leads. Didn't say that it did. Not so much test leads, maybe not the correct term. I actually didn't realize it came with any, and I got some, so now I got an extra set. Something down there, probably electrical cord, which is user replaceable. That's a good thing, as opposed to a not user replaceable cord. So that way when your cat comes and chews on the cord or whatever, you don't have to take it apart in order to replace it. Alright, so the power supply came in a plastic bag and a little silica gel thing so it doesn't get moldy or anything. You can actually tell whether a power supply is linear or switch mode just by looking at its current capacity rating and then lifting it up. If it feels like it has a big hunk of iron in there, it's linear, and it really does have a big hunk of iron in there. That's the transformer. If it was a 5 amp power supply and it didn't feel like it felt relatively lightweight, then it's more than likely a switch mode power supply. So these aren't as efficient at higher current draws, especially when you have a voltage regulator involved, but the output is a lot more stable than the average switch mode power supply. Okay, we've got the fan in the back, we've got the user replaceable power cord, voltage selector, and an exterior fuse holder. No operation serviceable components inside. So I guess I shouldn't try to service it while it's operating. Refer servicing to qualified personnel. Screw that. Warning: to avoid electric shock, the power cord protective grounding conductor must be connected to ground. Well, I know that's the third prong, and I don't want to get shocked, so let's see. Yeah, this one isn't quite long enough to reach the ground. There we go. Connected to ground. Not. Okay, now we've connected it for real this time. Now I'm going to turn it on. Okay, constant voltage. Let's turn it. Nope. Push, fine. Very clicky encoder here. I like that. Zero. Okay. raise it up to 1.5 volts, and see, you can set the current limit like this. Put it down to 1 amp for now. So whenever I want to change it, I just press it, and then I wait for it to stop blinking, and then it's locked. So every time I want to change the voltage, I have to press it. That might seem kind of annoying, but if you've ever fried something by accidentally turning the voltage up too high, which I haven't, knock on wood, or also a commendation to me being careful as well. But, you know, again, that's probably just to make sure that you don't accidentally fry something. So, it's actually a pretty good feature. Alright, CV, constant voltage. CC, constant current. There's lock. And then there's actually, I'm guessing overcurrent protection maybe, but isn't that what constant current would be? I mean, if the thing's shorted out and it's in constant current, then that would be the overcurrent protection. Push hold OCP on off. The binding posts don't feel terrible. Well, the holes seem a little small, the binding posts, for something that can supposedly deliver 5 amps. But if you make the wires into a hook, then the pressure against here, against the little ring there, should still provide enough contact surface area to deliver 5 amps. You've also got a ground terminal. That might be like if you had a anti-static wrist strap or something like that, you might want to connect it to there, for example. Alright, push, hold, lock, and unlock. Yeah. I'm going to look in the manual for a second. If you look in the manual, you'll see that by pressing and holding these two knobs in together for 2 seconds, that mode where you have to press the knob every time you want to change the voltage is disabled. So now I can spin the knob without having to press it each time, except to change where the number is. I actually like that mode, the default mode, personally. Because it makes a lot less likely that you'll accidentally change the voltage to the wrong setting. So, voltage adjustment, push and the voltage meter will flicker. Yeah. Push it to change the resolution. Yeah. Okay, so apparently overcurrent protection, which is the OCP light, is a mode you can set. So if with overcurrent protection mode off, you short the output, it just goes in a constant current and limits it to that level, but keeps the output voltage on at whatever level draws 1 amp, for example. But if you have the overcurrent protection mode on, like this, and you short the output will shut off completely and stay off until you turn the knob to rotate, to reset the overcurrent protection. Now, I'm assuming that the constant voltage light will turn off, or the volts will read 0 or something. I'm going to figure out what exactly it does. I'm going to lower the current limit to something like half an amp. go up to 5 volts. Alright, so the overcurrent protection mode is on. I'm going to short the output. Don't try this at home. It's set to 5 volts, half amp current output limit, and okay, volts just dropped down to 0. And then I turn the knob. Or actually, I press the knob. In the OCP mode, rotate this knob to recover the output. In actuality, I have to press the knob to recover the output, not rotate it. Or at least, not exclusively rotate it. So I turn it off, or I short it out actually. I turn the knob, voltage is 0, press the knob, voltage comes back. So they didn't tell the people writing the manual how the device works. Let's do that again, but with my multimeter hooked up, and I'll show you what happens. Okay, well, without a load, I've got 4.99 volts over here on this Radio Shack meter that I've had for quite a long time, so probably not in cal anymore, assuming it ever was in the first place, but close enough. A lot of times you'll see supplies that are actually 5.1 volts to account for voltage drop in the connectors and such, where such things are present. So let's see how good the resolution actually is. Okay, so at least it seems pretty consistent. Let me just spin it. Go up to, like, say 9 volts or something. We'll have to give it a second to settle, and I just heard the relay click in there, so it must be selecting another tap on the transformer. Okay, so once you let it settle down, it seems pretty consistent. Let's change it quickly and see how quickly it can catch up. I just maxed it out. And go down. Why is it going into constant current mode? That's weird. It said constant current for a second, but well, aside from that weird little anomaly there, the voltage did stay spot on. And now, without further ado, let's put a load on it and see what happens. Alright, so we've got a 4.7 ohm resistor. It is a power resistor. I'm not sure exactly the wattage. I'm only going to put half an amp through it because I'm not sure if it can handle more than that. And power supply won't suffer. If anything, the resistor would if I were to guess wrong on that, but I'm going to be on the safe side about this end. Actually, I'll hook my meter back up because I undid it to connect the resistor. So, I'll hook the meter back up. I didn't turn the output off technically, I just set it to 0 volts. So I'm going to set the current limit to 500 milliamps or half an amp, and I'm actually going to turn off the overcurrent protection, see how well the constant current mode works. So I'm putting my resistor on the line here, literally and figuratively. So I'm putting that little resistor on the line, power line, by turning off the overcurrent protection and seeing if the constant current mode holds up. Alright, so if you look closely at the multimeter, that's 1 millivolt when the power supply says 0 millivolts, or, well, 0 volts output. Okay, so I turned it down to 0 volts, and the current limit is set to half an amp. Now I'm going to increase the voltage slowly. You'll watch the volts climb up on the meter until the constant current kicks in. Alright, so when we get above 1 volt, the meter display is going to blank out for a second because it's an auto ranging meter. It does have a, yeah, see the current meter climbing up. Actually, let's try this again. I'm going to go back to 0. I'm going to manually set the range to the same resolution as that of the power supply. Because, really, if you ask me, it doesn't really matter if the voltages outside the range of the display are incorrect. Okay. So, it does have a 10 millivolt error on the display, at least from what I can see here. Again, this isn't a fluke meter, like fresh out of the box or freshly calibrated. This is so give it a second to settle down a little bit. Let me see how they're not plugged into there, but I was just messing around, see if that made any difference. I don't think it's the test leads because they seem pretty solid and touching them doesn't make a difference. Okay. Well, it doesn't say precision power supply anywhere on this thing, so and it was like $100, and some of these precision power supplies can be like, some of these like more precise power supplies can be like easily $300 at least. You can get a really crazy okay, constant current. It's reading it's reading 496 milliamps, and yet the constant current light is on when the limit is set to 5. That's weird. Okay, so the volts are dropping because of the constant current mode. I'm going to crank it up, see if it tries to go any higher, or if it just, nope, staying there. Bring it back down to... Okay, now I'm going to do that again, but with the overcurrent protection on. Not sure if it'll work with me changing the voltage at the same time, but just a little experiment. Oh, turned off. Even though I'm still showing the voltage, the constant current light went on so that I could see what happened. Now it's gone to 0 constant voltage, 0 amps, and there we go. Alright. So yeah, resetting it while it's still under overload will just cause it to do that. So it'll just trip off again immediately. Turning on the voltage doesn't do anything. You have to actually press the current knob, not the voltage knob, to reset it. Let's go back to 1 volt, reset it. There we go. You can hear the fan changing speed now and again as the load changes. That's what I expected, and at least it won't be running at max speed all the time, so it does at least have a thermally controlled fan. Not that hard to do by today's standards, but you know, if they wanted to save a few bucks, that's one way they could have done it, but they didn't. So I was a little bit apprehensive about getting a Korad power supply just because of Dave Jones from the EEV blog doing a review on this and having it go dead on him on camera. It wasn't this exact model, but the same brand. His was actually more expensive. But the thing is that according to the updates on his video description, I looked further into it, and they actually withdrew that model from sale and investigated the cause of the problem. So that was a good sign right there that they're at least trying to make good products, and they're not just in it for a quick buck that It also has a lock function as well, which might seem a bit redundant considering that in the default mode you have to press the knobs anyway to enable the changing of that setting. However, if you hold these 2 knobs down like I mentioned before, you can change it so that you don't have to do that all the time. If you want to be able to do that sometimes, but then, like, you know, you want to lock it, you just press and hold this button here. Now it's locked. And even if I press it, it won't do anything. I'm not sure if I can still reset the current limit, the overcurrent protection mode, while it's locked. I'll have to try that. But anyway, you want to unlock it, you just press and hold it again. It unlocks. Now I can change it again. So if I wanted to be able to quickly change the voltages without pressing the knob every time, for example, let's say I'm designing something that's gonna, in its final product, will run off of a battery that delivers, say, 9 volts. I mean, whether it's an actual 9-volt battery or some kind of rechargeable pack, a set of 6 AA's, but I want to see if my battery meter works, or the product continues to work properly when the voltage drops by, like, say 8.9 volts. I could have the voltage knob enabled when I'm doing that and not have to press it every time. And then when I'm done changing it for now, I can lock it. That way, I'm not going to come along, I'm going to, like, you know, be testing something here and, oops, I just fried the entire circuit. Don't. Nope. Not with the lock feature. As long as you remember to set it, that is. Alright. Yeah, for some reason when you're adjusting the voltage and you adjust through taps or adjust it quickly, the constant current light likes to come on. I'm not sure why it does that, but as you saw in the, like when I was doing the test, the output voltage was still tracking the setting when the load was nominal, so anyway. Okay, let's see if it still works. Overcurrent protection, yeah, no dip. Down to half an amp. Well, it says 1.5 volts out. Let's give the good multimeter a try. Hang on. Yep, still just as accurate as before. As I'm doing this, I realize I have a little tip I should probably give you guys to avoid damaging your circuits. Even if they're low voltage circuits, the circuit itself could still be damaged by an accidental short. So if you're wearing a watch, any kind of jewelry, you might want to take it off, or at least be aware of where it's going to be when you're working on something. Otherwise, you know, you might short something out and leave a burn mark on on your wristband clasp, or worse, like blow out a voltage regulator or something. Hopefully not this one, because it's current limited, so with the overcurrent protection off, it'll go into constant current mode. As you saw before, I tested it with the resistor, ramped the voltage up, and yeah, so anyway, I'll probably come back and let you know how well it's working, if it's still working after I've used it for a few weeks or so, and if anything goes wrong, I'll make another video about what happened, and, you know, depending on how Korad follows up, I might make another video about that too, if something goes wrong, which hopefully it won't, but, you know. Anyway, hope you enjoyed this video, and have a nice day.